All right, so in this video, I'm going to show you how to do Excel, to make a table in Excel, pull that table into Word, and add the components to the heading of the table that IB expects you to have for your IA. So I'll start by and you'll do the same thing. I'm going to put my incident angles, I'll just title that INC angle, and then my refracted angle. And these will be in degrees. So just make a little note for myself. These are degrees because we will have to convert to radians for Excel to use it. So to start with, I'm going to input my data, my values, and it doesn't matter if it's ascending or descending order. Please note, don't copy these angles. If you do, you'll get it wrong. And you need to have 1 decimal place of precision. The precision of the measuring device, or the precision of the measurements in this simulation, it was down to 0.1 degrees. So all of my measurements need to include 1 decimal place of precision. I just tried to type 45.0 in, and Excel automatically changes that to 45. But no, for IB, I want consistency. If I was at 45.0 degrees, that 0.0 degrees matters. So if I'm in the home screen under General, I can change the number of decimal places. I can increase the number of decimal places, and now I have 45.0. Good. The corresponding angle of refraction was 28.1. I'm going to keep doing this. I'll pause my video. That way I don't take too much time. I'm going to continue to input my data, my values. You should do the same, and then we'll compare. And voila, I have all of the incident angles, the angles of incidence, these are in degrees, and the corresponding angles of refraction. It doesn't matter what order I go in as long as horizontally they align. For this angle of incidence, this was my angle of refraction. Now, Excel does not do degrees. So now I'm going to add a column, and this will be, I'll call this incident rad for now. I'll come up with a proper heading in Word. So for the incident angles, I'm going to convert these to radians. So to do this quickly, underneath this heading, incident radians, I'm going to click the equal sign, click that into here, and I will type the word radians, R-A-D-I-N. R-A-D-I-A-N-S converts degrees to radians, open parentheses, and then I click this entry, close parentheses, and it's converted this 45-degree angle into radians. And if I grab the bottom right-hand corner, it changes the cursor to the black crosshair, and I can click, hold down, drag, and then release, and it will auto-populate the conversions for the corresponding entries. I'm going to, and you will do the same, you are going to change the number of decimal places to 3 decimal places, and I will show you why later, but we'll decrease this 3 decimal places. Okay, we'll do this for the refracted angles. These are in radians. Same thing, equal sign. I grab my degree for the refracted angle. Whoops, I forgot to type radians. Open, click, and then I click, drag, hold. Auto populates, change to 3 decimal places. So we're going to decrease the decimal. Looks very nice. Now we're going to take sine of the incident angles and rads. So again, your angles for Excel, they need to be converted from degrees to radians. So I'll do sine, returns the sine of the angle, and then I will input this number. Oh wait, I want a title. Sorry, let's put the heading up top. These will be sine incident equals, type the word sine, open parentheses. I will grab the first incident angle and rads, close parentheses. And then same thing as before, click, drag, hold all the way down. And again, I'll reduce the number of decimal places, just do 3 here. And then I'll have sine of the refracted angles equals, type the word sine, open parentheses, my first refracted angle in radians. And now click, drag, hold, auto populates, and again, reduce the number of decimal places to 3. Now, this table would not be sufficient for IB. They expect to have a proper table where you can get all the information from the headings. Note the lack of a need for trials. We haven't done like trial 1, trial 2, trial 3, or an average because this is a simulation. There's no random error, so there's no need to perform trials. If this was the internal assessment, I would discuss that. The drawback with using a simulation is you might lose a mark for personal engagement, but if your data is sound and the experiment is well constructed based on the simulation, you could still do quite well with the sim. So I'm gonna highlight these columns. I'm gonna make a table, and then I'm gonna pull that table into Word to add some of the heading features. So I will click Insert, Table. Where is the data for your table? Okay, it should be all of these entries that I highlighted, and click OK. And I'm checking my table has headers. Okay, so these are my headings. And I don't really care what the design of the table is in Excel. I can do any design changes that I need in Word. So while it's still highlighted, I go Control C. I hold down Control and then I click C and it copies to my clipboard. Now I go into the Word document and now I will go Control V. First thing I want to do is expand this table, make it fit the window entirely. So if I have the table selected, layout, where is this? Auto fit, right in the middle, auto fit. And I will auto fit the window. Boop, everything expands. Okay. It's not very evenly spaced. Maybe I can also try to auto fit contents. Nope. All right. Auto fit window it is. Okay. I will start with my headings because this is really what's going to need to change. First, let's change it from white to black if it's not already black. Black is easier to see. Also, let's go ahead for this table. If I highlight the whole thing, table design, we want to put borders. It's easier to see if we have all the borders highlighted throughout. So, okay. All right. Typically, your headings are emboldened, so that's good here. And personally, I like to see things centered. You don't have to, but it's what I think it looks nice like this. Okay. Now, IB expects to see a few things for each of the headings. It needs to know what those quantities are. So for example, this will be the the incident angles. Oops. My heading for this column, incident angles. It expects for you to have a symbol to represent those measurements. So in this case, the symbol for the angle is theta. So I will go to Insert. I will go to Symbol, where it shows this capital Omega. If I click down this down arrow, it gives me my most recently used symbols. Your most recently used symbols may or may not include the Greek small letter theta. If it doesn't include the Greek small letter theta, we'll go to More Symbols. And under the Greek and Coptic, you'll see the lowercase theta. Insert, close. All right, so, and I'm going to give this a subscript. So this is theta control plus for a subscript, INC. And notice, okay, Word, it capitalized that, and I'd prefer it not to be capitalized. So if I go to home, I can change to lowercase, bam. So this, I need to include underneath the heading for what the measurements are, a symbol for the measurements, including any subscripts for that symbol. If I want to get out of the subscript, I can click Control plus again. And then I need to include the units for this measurement. I can do a slash and the units, and they want the symbol for that unit. Or I can put the unit in parentheses. Either way, in this case, I'll just use a slash, but this was in in units of degrees. So I will go Insert again, Symbol, and I'm going to get the degree symbol, which I've already used. So I go back to More Symbols. And if I go to Latin 1 Supplement, there is the degree symbol underneath the lowercase v. Insert, and once you've inserted it once, it'll be in your quick symbols. Okay, so I have the title, incident angles. I have the symbol for those incident angles, theta incident, slash the unit in degrees. One more line. Now IB expects you to record what the uncertainties for these measurements are. So the uncertainty of these measured values, to show that I need to input this capital Greek letter delta. If you don't know where that is, it's Greek. So go to the Greek and Coptic, and you should see a capital delta, this triangle shape. Insert, close. Delta theta incident. So I'll just go Control C and Control paste that word, and then Control plus to get out of the subscript. And this is going to be equal to, insert this plus or minus symbol. So again, I go to symbols. If I don't have the plus or minus on hand, more symbols, and this will be again Latin 1 supplement, and you should see the plus or minus symbol underneath the W. Insert, plus or minus, and then this is where I record the precision of the measuring device or the precision of the simulation. The simulation went down to plus or minus 0.1 degree. And I can just insert the degree symbol right here. Okay, I'm going to pause the video now and I will do the same thing for the refracted angle. And then we will discuss the uh, incident in radians, refracted radians sign. So pause. I'm going to pause and make your heading here for the refracted angles. And voila, I have filled out the other aspects of the headings for this table. So what you see, we did these two here. And then I also added the incident angle, refracted angle title. Now the theta is still, the symbol for this measurement is still theta sub inc slash, now we're in radians. I still will include the uncertainty, the absolute uncertainty in these angular measurements or conversions. And to do this, all I did is I converted the uncertainty in the degree. I converted 0.1 degrees to radians. So to do that, if we forget, you take the degree, you multiply by pi, and you divide by 180. And it's 1.74 times 10 to the negative 3. And so I just have to use my best judgment in this case, especially with these types of conversions. I went ahead and I converted to just 1 sig fig. Here it's a sig fig, so I feel like it's a reasonable thing to convert or to round to 1 sig fig of precision. I'm sorry, 1 sig fig for the conversion, so 1.7 times 10 to the negative 3. I just round that 1 up to a 2. Same thing for here, and everything should be aligned. If I have 1 decimal place of precision of uncertainty, all of my values need to have 1 decimal place, this 11.0, this 45.0. For my incident angles and radians, or my refracted angles and radians, everything is rounded to 3 decimal places of precision because that's down to the lowest value. This is 3 decimal places here, 3 decimal places here. What I've done now for the sine of these angles, this is a unitless number. So all I have this titled as sine open parentheses theta sub incidence, sine open parentheses theta refracted. The uncertainty in these values, if I take, what I did is I did sine of the uncertainty to get the absolute uncertainty in these values. And notice, make sure your calculator is in degree mode. So go to mode. If you see it's in degree, for right now, change it to radian because this is our little intro to the small angle approximation. If I have a small enough angle, typically like less than 0.01 radians, it turns out that if I take the sine or the tangent of that angle, it's equal to the angle itself. It works for small numbers. So try typing it in your calculator. I'm doing sine 0.002, and the answer, sine of that angle, is equal to the angle. So make sure that your table has headings, symbols slash units, and then you have all of the uncertainty values. Sine of an angle, it's a ratio, so it's unitless. And to get the uncertainty in those angles, I took sine of the uncertainty value. It's not technically how you're